Okay, so let's get started here with lecture 12. Talking a little bit about Matlab scripts and functions, although like I said, it's mostly going to be supervised project time for a bit here because I did not know that the Matlab fairies were going to visit us overnight and get our Matlab installed. So the good news is I did have some Matlab demos planned for today to kind of ease you guys into the Matlab programming language. So actually that's great that you guys can now follow along. But I didn't have a bunch planned because I didn't realize we were going to be able to do Matlab the whole time. Okay, so let's go ahead and get started. This is so I've gone to a new webcomic because I ran out of XKCDs mostly that were relevant to programming. This one illustrates what I'm trying to avoid doing as much as possible with this class, where I'm trying to give you guys some overview of programming concepts, but of course, like this comic suggests, you can keep explaining until you get into a level of analysis that's like far, far below what's useful to you. But I'm trying to also avoid, well, come on, clicker. I could just hit the key, but what's the fun in that? I'm trying to avoid this explanation too, right? So we're trying to target something in between these two levels as we're going through and doing our computer programming lessons. Okay, so just to revisit the topics, we're up to what should be this today, but again, we're sort of slowing down our focus on Matlab due to the software installation situation. But I am going to talk to you a little bit about Matlab scripts and functions, and we'll get into PsychToolbox next time, especially once I confirm that this Matlab is here to stay. Okay, so in terms of administrative stuff, it's been a bit of a crazy beginning to the semester, but I am really almost done with your problem sets and project proposals. I actually have finished all the project proposals. I have some comments, but nothing like everyone's projects were good enough that I didn't feel like I needed to say stop and do it a different way, so that's good. Problem set 6 I'm nearly done with. Should be done by tonight, and I'll send them all out at once. And I will construct, my plan was to have handed out problem set 7 already, but of course I couldn't give you a Matlab problem set until we have Matlab. So maybe I will construct problem set 7 once I confirm that this Matlab installation is not going away. Okay, so really seriously almost there. Any other questions or anything before we get started or comments?
Can I make a shout out?
Sure.
It's Eileen's birthday today, and I would like everybody to wish her happy birthday.
All right, everybody, happy birthday! Yay, it's on the podcast. It's there forever now. Yes, happy birthday. I hear it's also Ian Stevens' birthday, although I haven't said that to him myself yet, so happy birthday to him too. Okay, so I don't have any new real lecture stuff to actually do today. It's just demos. So I thought I'd start off with a little flashback to last semester, though. Our old friend, the number guessing demo, if you guys remember the number guessing demo. So maybe I'll refresh your memory if you have forgotten it. So what I wanted to do today was, again, sort of ease you guys into sort of the programming of Matlab and the language, and to mainly focus on these similarities between the Python and Matlab programming languages. So if you can remember, we did a bunch of versions last semester of this number guessing demo. We can even do it right now. So exec file, if I can remember how to do this, number guessing. Oh, you know what? I have to do all the weird steps, like I have to hit run first, don't I? Okay, exec file number guessing demo 3.py. What did I screw up? Oops. Probably screwed something up. All right, this should have normally worked, right? Exec file number guessing demo 3.py. Oh, I think I missed an underscore. Okay, so remember it said hello world, I want you to think of a number between 0 and 100. When you have one, press enter. I would press that. It would try to guess it. No, it's not 50. Should I guess higher or lower? Let's say higher. Is it 75? No, let's say lower. Is it 62? Sure. Sounds good. All right. Everybody remember that awesome, super fun game that we had for like 6 weeks last semester? So I figured one interesting thing that we could do, well, not that interesting, but somewhat interesting, is to see how quickly we can turn this from a Python program into a Matlab program so that you guys can kind of see some of the similarities and differences. And so hopefully you can see that it's not going to be super painful to learn the Matlab programming language once you guys know the Python programming language. Now again, I realize that it's going to be very hard to deal with some of the minor issues, just like remembering to use the right commands and to put semicolons at the end of Matlab statements and things like that. For example, you'll quickly see that while loops in Python require a colon at the end of the while statement. MATLAB do not. So you're constantly, once you start switching between languages, you're constantly going to either be putting colons where they don't belong or forgetting to put a colon where it does belong. But that little stuff like that, that's not a big deal. But I want you to see that overall, in general, it's actually going to be pretty easy to convert this number guessing demo from Python to MATLAB. So what I'm actually going to do, and you guys can follow along and do this if you want, is I'm going to make a MATLAB version of this. And I'm going to start by literally just pasting in the Python code and seeing what I have to modify to make it run. So I'm going to, if you guys remember, you can launch the MATLAB code editor by using the edit command here in the command window. And I'm going to call it number guessing demo. And it says, all right, that doesn't exist. Do you want to create it? I'm going to say yes. And by the way, where it creates it is right here in my, in this case, this is my current path. So in my documents folder on the Mac and in a subfolder called MATLAB. You guys probably all have a similar subfolder on your MATLAB installations on your desktops. That's where I'm going to recommend you keep all your MATLAB files. Because again, MATLAB, when you run a MATLAB script, it has to know, it either has to be in the current folder or it has to know what folder it's in. And it always knows to look in your user MATLAB folder, wherever that is. And on Windows, it's in the equivalent, I think, documents MATLAB subdirectory. So my recommendation is, I wouldn't recommend this if you're like a professional MATLAB programmer and you have hundreds of scripts because keeping them all in one directory is kind of messy. But for you guys, I would suggest keep anything you're working on in this one directory and your life will be simpler. So, all right, so we're just going to let it create a document in, you see in my MATLAB folder. If you came in late, by the way, MATLAB seems to have mysteriously showed up, so you can follow along if you want. So you see that another nice little thing, I just said to call the file number guessing demo, but MATLAB automatically adds the .m to the end of the file name because all MATLAB code files end with .m the same way that Python ends with .py. Okay? Everybody cool so far? Everybody got their MATLAB working if they're following along? All right, so all I'm going to do, I know you guys don't have this code to paste unless you want to go back and find your, this is from number guessing demo 3.py, I believe, from like lecture 6 or 7, something. I think lecture 6 or so, maybe 5. But that's okay, you don't have to do it because I'm going to be changing this code anyway. What I want you to see is that, here's Python code in a MATLAB file, which, just feels dirty and wrong if you're used to this stuff. So it's not really valid MATLAB code. And I can prove this to you by saying number guessing demo. Oh, look at that. Not surprisingly, by the time we get to line 13, we get expressions that MATLAB doesn't know how to interpret. Although that's actually one thing that's cool about that. That's pretty far, right? So somehow I was able to get through the first 12 lines or so as that being valid MATLAB code before it crashed. So that's kind of cool. Now you'll notice it didn't actually run anything in this demo. And if you also look, you can see that I should have known it was going to crash when I tried to run it because, like I said, MATLAB's got this great code analyzer. Up here it gives me a little red square, which means there are fatal errors in this code that will make it impossible to run. So a red square is like your code will not run. An orange means there are warnings, but it is runnable code. And a green means that MATLAB can't find any problems with your code and that you're probably going to get a really good mark on your problem set. So that's just a little, it's same as stoplight colors, right? Same basic idea. So if you go into the margins where you see all these little notches or little color bits, you see that if you look at them, it'll tell you, all right, line 13, there's like a fatal red error, but like at line 16, it's not a fatal error, but it's a warning saying there might be a better way to do it. Now again, obviously there are going to be errors and warnings because this is Python code, not Matlab code. But let's just see how we can fix this up. Well, one thing we're going to do, there is a statement called print in Matlab, but the preferred statement to use is usually called disp. So one thing I'm going to do is just go through and replace all my prints with disp. That's going to be a bit different anyway, so we're gonna wait on that because we're getting input there, and that's going to be a bit different. Okay, so that's one easy thing to do, right? It's just remembering that the equivalent of print is disp. All right, easy enough so far. Okay, so the next thing we do in this code is we get some input. We use this Python function called raw input, right? If you guys can remember back. Now, again, when you get into making a lot of real MATLAB code or Python code, you don't generally use that text input all that much, but there is a MATLAB equivalent of this Python raw input function. It's called input, and if you want to see how to use input, you can, remember, like I said, you can type help and the name of any MATLAB command in the main MATLAB window, and it'll give you a nice little short manual as to how to use it. So it tells you that if I say something equals input and then a string, it gives you the prompt and then waits for input. The key thing is, if you kind of read on, if you want numerical input, you can do it that way. So if I want to say A equals input number of apples, I can do that, and I can say like 5. And then A is going to hold my number of apples, which is 5, which is very similar to how the Python input command works, right? But if I say the same thing and I try to put lots, it doesn't like that because input by itself wants a number value. If you want to get a string from the input command, there's a slightly different way you can use it, which is to use the input command, and after the first argument to the function, and by the way, you see that MATLAB functions have a very similar syntax to Python functions, right? You say something equals name of the function, parentheses, and then whatever you're sending into the function. So hopefully that looks really familiar to you. So you can use this function with one string, which is just what's displayed to the user, or you can put in one string and then a comma, and then you can put in just the string s, which is just a cue that you want a string output, okay? And there's other stuff you can do, but that's the main thing we want to do for now. So in this case, answer equals raw input. Well, we could do it either way, because actually all this one's doing is saying press enter to continue, but we may as well ask for a string. So we could do that, right? So that's not that much of a change. We changed raw input to input, because it's just a different command name, and we added a .s to say that we might be expecting string input. All right, so we're doing pretty well for changing this over so far. Now, if you remember, MATLAB didn't complain about these 4 lines at all, right? If you remember how we did this, we created 4 variables, one to represent the current number we're guessing, one to represent the minimum and maximum values we might guess, and one is to represent whether we've guessed correctly yet. MATLAB was okay with those 4 lines, except there's going to be one problem if we try to run this. And I'll show you the problem line. This is also why MATLAB's going to be like slightly infuriating to you. So if you try to say, let's say A, we want to now make a true-false value. If we say A equals false, that doesn't work. Because in MATLAB, false has to be not capitalized. So in Python, it's capitalized. In MATLAB, it's not. Just another one of those silly little things you have to remember. All right, so we're going to change the F in false to lowercase. But again, not that different code so far, right? The biggest thing that's going to change is what's in this while loop. But again, you'll be surprised at how much it's not different. Okay. So a couple things we have to change in this while statement. Again, these are just kind of things you have to know about the syntax. They're not particularly meaningful. It's just, again, it's like if you go from American English to British English. I think in American English it's more common to use double quotes, in a book or somebody says something in a British English, it's more common to use single quotes. There's no reason, it's just different punctuation, right? So same idea here. It's saying the same basic idea with different punctuation. So like I said, while loops in MATLAB do not require, in fact, they don't even want a colon at the end of them. So you take away that colon at the end of the while loop. And the other thing is that there's a different way to say not in MATLAB. So Python uses the word not. MATLAB uses, it's the circa or approximately symbol. It's the one, hopefully on your keyboards, yeah, it's the one to the left of the one key if you press shift, right? So it's like the ñ that goes on top of n's in Spanish sometimes, but it's technically called like the circa or approximately symbol. Everybody found that one? Well, this is getting into typography nerdery. Technically speaking, it's only called a tilde when it's above an n. Otherwise, it's the circa or approximately symbol. I mean, yes, it's a minor difference, but yeah, technically, I mean, they're both squiggly lines, but technically a tilde is only something that appears above an n. Okay, so yes, you can call it the tilde, you can call it the circa symbol, whatever you call it, it's that squiggly line guy, okay? So that's how you say not. The word not does not mean anything special in MATLAB, so again, it's just something you have to remember. It's just a weird symbol meaning not, okay? If you want me to prove that to you, false is, remember how we said false is just a fancy name for 0, right? So false is 0. If we want to know what not false is, it's 1, right? Or if we want to know what not 1 is, it's 0. Not 0 is 1. Does that make sense? Not true is 0 or false. Okay, that kind of makes sense to everybody. So that's what not does, or not. That's what not is in MATLAB. Okay, so no major changes yet. One little change here. So there's a couple issues with these couple of lines. One is that we know we're going to have to change the raw input function. So that's fine. We can do that. Another thing is, here's something a little bit funny. So anybody got an idea? This was a line of Python code before, remember? And you remember we used that funny little % operator to indicate that we wanted to insert the current guess where that little %r is in the string. Anybody know why this text is green now? Why MATLAB's highlighting it as green? All right, well, and something was highlighted. Well, you could see some things are already highlighted that probably make sense, right? You see that in MATLAB code, by default, strings are pink, regular text is black. Special words like while and if and else are blue. What other, in Python, what other kind of text got a special kind of formatting? Anybody remember? Well, we got a few things, right? Python would highlight numbers for you, which MATLAB doesn't. So in Python, same thing, right? Green, you guys remember green were comments? All right. So another little stupid difference. Python comments start with pound sign or octothorpe or whatever you want to call it. In MATLAB, comments start with a % sign. So if you wanted to put a comment in, you would start a line with a % sign. You could put like Python sucks MATLAB forever, something like that, right? That's just a comment. MATLAB doesn't interpret that. Hi, John, if you're listening. Okay, so we're going to need to replace this, but actually, we're going to have to replace it anyway because MATLAB doesn't have a statement that works quite like this little %r thing does in Python. So what we want it to really say is it blank? So there's a couple different ways we can do this. I'll do it, this is not the way I did it when I first kind of worked through this, but I think I'll do it a different way to make it a little simpler. So what we're basically trying to do here, right, is take a number and make it part of this text string that we're asking, that will then be what's displayed to the user, right? So we need a way to turn a number into a string. So I can show you how to do this in the MATLAB command window. So if we set our faithful temporary variable named a to, let's set it to like 23. So a is now 23. You can do something like, you can say disp a. Oh, that's, I lied. You can't do that, actually. You can say disp. So if you tell it to display the variable a, you can do that, But that's not really making a string of it. That's just displaying a representation of the number 23. Right? So A is still a numerical value of 23. And remember, we've got our little workspace up here that tells us all the variables we've created. If you scroll over and look at what A actually is, it doesn't tell you, but you can set it to tell you what kind of variable it is. But you can tell it has the value 23. So if we want to make a string that has the number, a text representation of the number 23, like that, that's easy enough to do, right? And you see the difference in the workspace is that this is the number 23, this is the string to the character 2 and the character 3. Everybody, that makes sense to everybody, the difference? So you can do A plus 5 and get 28, but you can't do B plus 5. Well, the reason you get that is complicated and not worth going into right now. But you don't get 28, right? So the string of something is not the same as the number itself. Okay, so what can you do if you want to start with the number 23, or the variable A, and get something like B here that is a string? So there's a couple of different functions in Matlab that can do this, but let's use one that's just called num2stir. So if we do that, you can see that if I say C equals num2stir parentheses A, what that means is C is going to become a number converted to a string, whereas the input is A. And you see that C now has the string representation of 23, right? So that's a super convenient function. Now everybody kind of get how that goes? So that's just a function that turns a number into a string, right? And again, Matlab has a million functions. You just have to kind of know them all. Well, you never do know them all, but if you're trying to learn how to do something in Matlab, chances are pretty good if it's something kind of basic, it has a way of doing it, which is one nice thing, that Matlab has a lot of this stuff built into it. So we know that there's this function num2stir that will turn our number, our current guess number, into a string, but we still need to insert it into this is it whatever string, right? So what I'm going to do is I'm going to make a variable called, let's call it like prompt string equals. And I'm going to do another sort of tricky little Matlab thing. And I'm going to say, put part of the string below in there, is it, then I'm going to put my, num2stir current guess, and then it's going to be the rest of the string, y/n, question mark, space, close the square brackets. Hopefully you guys can see on this. Yeah, you can kind of see what's a square bracket. And that's good. So I very briefly got into this the other day, not too much. But if you remember, I said that everything in Matlab is a matrix, right? So that means if I want to make a new matrix, let's say I want to make a variable called D and it's a matrix, and I want to put the numbers like 50 or 65 and 43 and 99 in it. I can do that, right, by putting them in square brackets, just like you put matrices in square brackets in mathematical notation. That makes a matrix, or a list, but a list that can be any number of dimensions, out of this D that has these three numbers, right? So you, like I said, everything in Matlab is a matrix. So even if you have a string is actually a matrix. So essentially what you do is if you put a bunch of strings inside brackets like this, it's going to make a bigger matrix that is all the strings joined together, right? So that's just another way of saying this is a way of joining strings together. So for example, if I wanted to have the variable E equals hello, right, and the variable F is friend, if I want to see what that is together, I can make a matrix that contains the elements in E and the elements in F, and that joins it together and makes one matrix that is E and F combined, right? So if I want G to be the matrix consisting of the elements of E and the elements of F, G is now hello friend. Does that, again, I know this is kind of confusing to think about, but this is an easy way to join strings together in MATLAB. And the cool thing about that is, I mean, again, the idea is you have to start thinking of a string as not being like just a chunk of text. A string is really a matrix. So if I want to do the size of G, G is a 1 by 13 matrix of characters, right? So that means there are 13 characters in hello friend. That means what you should really think about it as is this like list of an H, then an E, then an L, then an L, then an O, then a space, then an F, and so on, right? And so again, the nice thing about matrices is you can combine them, you can do math with them, and so forth. So hopefully this kind of makes sense. I know it's a lot all at once, but again, this is just kind of easing you in. This will all be on the podcast, obviously. So we're not doing. That's probably the most complicated thing we'll do today. Okay, so what we're going to do is we've now built the string that we're going to use. Okay, but we need to still get input with it. So we can actually get rid of this line because we've done a different way of making the prompt string. So now what we need to do, instead of printing it and using raw input, we need to use input like we did up here and say answer equals input. And now we can use the prompt string that we've created. And again, remember, if we want text input, we have to end it with just the string s as the second parameter to input. Whoops. Okay, so that's all good. So that's valid MATLAB code now. And there's not too much else to do. I mean, there is a fair bit else to do, but we're almost there. So one drastic thing, let's before we sort of go line by line through the rest of this, let me introduce one more sort of major difference between how you express MATLAB and how you express Python. In Python, remember we said the structure of your code is all dependent on your indentation, right? So if you have a while loop and then an indentation, everything that's indented isn't part of that while loop, right? MATLAB is different. So MATLAB, it is certainly highly recommended to indent your code the same way that you indent Python because it makes it much more readable. But it's not strictly required. But what is strictly required is you have to explicitly say where the end of each loop is, or the end of each if statement, okay? And the nice thing is it's pretty easy to remember how to do that. It's with the word end, okay? So none of these ifs and whiles and so forth are going to work until we actually end them. So that's why we're getting these big red errors, is because this is not valid MATLAB code until we close up these loops. And also, while we're at it, let's go ahead and get rid of, like I said, none of the ifs and whiles and elses and fors. None of those need a colon at the end. So let's get rid of that colon. Let's get rid of that colon, that colon, and that colon. One other thing that's a bit weird, I think I mentioned this last time. If and else and while are all the same words in MATLAB and Python, but elif is a weird Python thing. So the MATLAB version of elif is else if, all spelled out, right? Because you saw it wasn't highlighted in blue before, which means elif is not a special word to MATLAB. But else if is a special word indicating the structure of the program. So, so you need to change it elif to else if. And now let's actually go, and again, here's one great thing about MATLAB. You'll see that MATLAB, kind of like Python, if I'm at the end of this line here, and I hit enter or return, my cursor goes here, right? It assumes I want to put another line of code right here, but let's say I want to end my loop. I just type end, and you see what it automatically does. Let's do that again because it was so magical. Watch closely. E, N, D. Magic! So it does a couple things, right? It highlights the if statement, indicating that this end ends the statement that begins with this if, right? So it's an if, else if, end, meaning that these are all one block of code. And it magically unindents the end because it wants the end to line up with its corresponding if, right? So that's really nice. MATLAB will actually kind of help enforce good code style as you go so that you don't have your ends and everything all out of alignment. So again, MATLAB wouldn't really care. Like if I want to just go nuts and like indent this line all the way out here, that is still just as valid as it was before. But don't get out of the habit of indenting, because indenting is always a good thing to do, even though in MATLAB it's not strictly required. Okay, so that's one end statement. So now you see I'm down here. If I type another end statement, Ooh, now that closes up this if statement here, right? If, else, end. And then I also need to close off this while statement, which I've now done. You see how that got rid of all my, when I finally put those three ends in, it got rid of all my nasty red flags. Now I've still got a bunch of warnings that we'll deal with later. But that's actually gotten rid of everything that makes the code impossible to run in terms of the Matlab language. Now, code would still break, for example, like here, because there is no raw input function in Matlab. But there's no problem with the grammar of the code, basically, at this point. Okay, so that's good. So that gets our nasty red errors done with. There's a few other things we need to do. So let's do them. So this is an easy one because we've already replaced all our other input stuff, right? So we just replace raw input with input here and add an S at the end to mean we want a string input. That fixes that one, right? There's something easy we can fix on this line. What is it? Okay, yeah, lowercase t on true, right? So just how in false we had to, oops, it's not true, it's true. Right, so just how we had to put a lowercase f on false, we have to put a lowercase t on true, because in MATLAB true and false are not capitalized. So that's mostly it. Now, there's a bunch of stuff we should still fix. And MATLAB is telling us what we should fix. So again, this is what's great about this MATLAB code editor. All these little things that are highlighted in little kind of beige squares, it's telling us where the problems are, right? These are, again, the equivalent of the squiggle that underlines your grammar errors in Microsoft Word. So you can either highlight a potential warning here, or you can look at sort of these bars correspond to like where in the code they are, right? So this is like line 4, line 11. Here's something at the very end, line 28. So it kind of gives you an idea of where stuff is in the code. But you can also look in the code itself if you've got good eyes, mouse over the thing that's highlighted, and it tells you the issue, right? Now, let's see what this says. The nice thing is, again, it will actually automatically offer to fix stuff for you. But I don't want you guys to get in the habit of using this because you don't necessarily know yet the right way to fix stuff, so you don't have a good way of telling whether MATLAB is doing it right. So don't just click fix, because it may not fix it the way that you think it should be fixed. But it's telling us there is a problem, probably. So it's saying terminate statement with semicolon to express output within a script. You guys remember what I said about MATLAB and semicolons before? So it's pretty easy to show again. So if I have, let's make another new variable called h. Maybe h is going to be like 999. If I assign a new value to h and just hit enter, by default it prints whatever was just assigned. I have no idea why. This is just how MATLAB does it. And that's kind of useful in the code editor. Not for this, for example, but if I wanted to do something where I didn't know what the output would look like. So if I wanted to say like, let's say instead that h is going to equal a random set of numbers that's 3 down and 6 across. Of course, I didn't know what those random numbers were going to be ahead of time, right? So it's kind of nice to see what the output is. But you don't always want to see the output, right? Because like I said last time, if I were doing like 1,000 by 1,000 matrix of random numbers, I don't necessarily want to see all that output, right? So if you just type a semicolon at the end of the statement, it does it, right? If we go into our workspace viewer, we see that h here is now a 1,000 by 1,000 matrix of numbers. But it doesn't print all those values out, right? So a lot of these issues here are just telling us that every time we assign a variable, we probably want to put a semicolon at the end so that it doesn't print out every time we change a variable in the script. And here's a little tip. Even if a statement does not produce like change a variable like these do, it doesn't hurt to put them at the end of things like this statements. So my advice to you is put a semicolon at the end of every line of MATLAB code, except for one case. You don't put them at the end of structural lines like while loops, okay? So where you do put a colon In Python, you should put nothing in Matlab, okay? So any other regular line of code, you can put a semicolon at the end of, but not whiles, ifs, elses, fors, and so forth. But any other line of code, just get in the habit of putting a semicolon at the end of every line, and you'll be much happier because you won't have like the script that runs perfectly but produces like pages and pages and pages of output so you can't actually see what it's doing. Okay. So we added a bunch of semicolons. That's pretty good. So now we're down to 2 random little warnings. And this is not bad either, actually. So this is saying, right, here's where we're testing to see if like what the person entered in was the word higher or the word lower, right? What this is saying is Matlab, can it do that? Let's see. So let's say, let's create the variable answer, and let's say it's higher. Let's see if answer equals higher. Okay. This is another weird feature of Matlab. So if I want to test whether answer is equal to the string higher, I get that output, which is not just a yes or no. Anybody have any idea why it's doing that? Well, let me help you out. Let's just put a couple random letters in there. Like now it's, let's see if answer equals the word Hector. We'll get that. Anybody see what it's doing? So we assigned the string answer to be the word higher. We tested to see if answer was equal to higher, and we got 111111. Then we changed it to see if answer is equal to Hector. We got 110011. So what changed there? Okay, so where we changed the letters, the C and the T, we went from 1s to 0s. So again, this is one of those weird things you have to get used to about how in Matlab everything's a matrix. So if you test to see if like one number is equal to another number, that just gives you one output, right? But if I test to see whether one matrix is equal to another matrix, that gives you a truth value for every element in the matrix, right? So another way of doing it is, let's say we want to compare 2 matrices like 2, 4, 6, 8. And let's see if that's equal to the matrix 2, 9, 6, 5, or something like that, right? That gives us 1, 0, 1, 0, the matrix 1, 0, 1, 0, meaning that the first element's the same, the second element's different, the third element's the same, the fourth element's different, right? So again, a weird thing to get used to in Matlab is anything that, generally speaking, anything like any operator, like the double equal sign to test for equality, if you put a matrix thing into it, which includes both numerical matrices and strings, it operates on them like a matrix and produces a matrix of output, right? So that's generally, when you're comparing 2 strings, that's generally not what you want to do. You can imagine how if you're doing mathematical stuff, this is really useful. I'll give you a quick example to how this is useful. I promise this is useful. So let's say you're doing a psychology task and you had a matrix called subject responses. Let's say they were doing the task that we had in that problem set 6 where they, well, let's do the one where they were doing that MSET task where they had to press 1, 2, or 3. So let's say we had a list of responses where they responded 1, then maybe the next time they responded 3, then maybe the next time they responded 2, and then the last trial they responded 1 again. Okay, so they just did 4 trials. Those were the subject responses. And actually, you see, Matlab tells me, you dummy, I could have just put in the string 1, 3, 2, 1, because the matrix of these 4 single characters in a row is the same as just the string 1, 3, 2, 1. But let's say the correct answers is, let's say the correct answers are 2, 3, 1, 3 again, and 1. Okay? So the person responded 1, 3, 2, 1. The correct answers are 2, 3, 3, 1. If you want to see what the subject's overall accuracy is, in Python you would have usually done a for loop, right? You can make a for loop and you can compare each element in each list. In Matlab, one nice thing is you can just say, does subject responses equal correct answers? and you get a 0, 1, 0, 1, which means one wrong answer, one right answer, one wrong answer, one right answer. And if you wanted to see like what their average was, you could put the same thing in, but you could use the mean function, and you'd see that their average is 50%, right? So you can do something pretty sophisticated in one line of code, right? You can compare every element in two lists to see if they're equal, and then average them to see what their correct response rate is. So it's pretty powerful when you start thinking matrix-wise. Okay? Now it's a very long way to say a very simple thing, which is just that Matlab wants you to not use the double equal sign when you're comparing strings if all you want to know is if the strings are identical. Okay? So the right way to do this is there's a function called strcmp string compare, and that will do what we really want it to do, which is to compare these two things and see if they are both equal. But it doesn't give us a matrix, it only gives us a single output. So if you want to confirm that, like let's see, where are my two? So if I want to so in other words, if I want to see if subject responses equals correct answers, I get 0, 1, 0, 1. If I want to do a string compare between subject responses and correct answers, it just tells me 0 or no, that they're not equal because they are not the same exact string. But if I say stir E, if you remember E over here is just hello and a space. That's true. Now again, it has to be completely exactly identical, because if it's hello without the space, it's 0, right? Because I put a space in E in the string that is denoted by the variable E. So strcomp just tells us if two strings are completely identical, which is what we really want to do. And although it didn't complain, it's probably not the worst idea to do it here too, just to get into the habit. Because if we wanted to change Y to yes, we'd have to replace it with strcomp. So really, anytime when you're comparing strings, you probably, unless you know what you're doing, want to use strcomp and not the double equal sign. Okay, now, finally, 42 minutes later, we have a little green, no warnings found, which means in theory, we can run our number guessing demo. Hello world. I want you to think of a number between 0 and 100. When you have one, press enter to continue. Okay, I'm going to try to guess it now. Is it 50? Say no. Should I guess higher or lower? Higher. Is it 75? No. Should I guess higher or lower? Lower. Uh-oh. Oh no. Oh dear. So we have one problem here, right? Is that we found another difference between Matlab and Python. So what's the issue here? Well, what's the difference between how Matlab and Python treat arithmetic by default? Like if we have a line like this, if you guys remember this, this is where we, average our current guess and the current maximum, or the current guess and the current minimum to change our guess. What does Python do when you divide an odd integer by 2? All right, yeah, you guys remember, so we try it. Like 5 divided by 2 just gives you 2, right? It just lops off the decimal part. Matlab, like we said, doesn't default to calling things integers. It defaults to using a decimal representation of everything, right? So 5 in Matlab is really 5.000. 2 is 2.00. So 5 divided by 2 gives you what to me seems like the more logical answer most of the time, 2.5, right? The only problem is that's not what we want in Matlab, right? In this case, we actually want to stay working with integers. So what we have to do is, there are like 3 functions that if you're ever dealing with numbers, you'll probably want to know. The one that we're going to need right now is called floor. Okay, it's called a floor function because what it does is it says, if you're, imagine that we're hovering, like our floor is the number 2 and our ceiling is the number 3, right? If we're floating somewhere in between the floor and the ceiling, because we've all suddenly started levitating for some reason, the floor function will take that value and plop it down to the floor, right? So if you've got something in between 2 and 3, the floor function will make it 2. Now if you want to stick it to the ceiling, use the ceiling function, which is ceil, C-E-I-L, right? So ceil bumps everything up to the next higher number if it's in between. Now, one thing to note is if you have a number like an integer, floor of it or ceil of it won't do anything, right? Because the one man's ceiling is another man's floor, right? So, so whether you do, I wasn't even trying, that just came out. So, you know, when something is already an integer, a floor and a ceiling of it is equivalent. But if you have a non-integer like 5/2, that's important. And the last one that you might want quite frequently is very similar to Python. There's a function called round. Now round will, if it's exactly like 2.5, it'll round up to 3. Usually, I think. Let's just, round does some weird things sometimes. Yeah, round is a bit funny. Oh no, that's right. That's what it should be. Okay. There's a whole mathematical discussion of rounding that's outside the scope of this class. All right, so that's what's semi-logical. But if you had something like, you know, in other words, if you round 1.333, it gives you 1. But if you round 1.6, it gives you 2. Right. So floor, ceiling, and round are 3 easy ways to turn a non-integer value into an integer when you want an integer. So in this case, to just emulate exactly what Python did, the easiest thing to do is just say, put a floor around this mathematical expression, right? And then that'll do, like what we had originally was not syntactically incorrect, but it had a bug in how it ran. Now we should both be able to run it and get the correct behavior. So, is it 50? No. Higher. No. Lower. Hey, cool. No. Higher. No. Lower. Let's say it's 65. All right. Yay. I knew it. I'm awesome. All right. So fond memories of last semester back when this was all you guys could do in Python, right? Okay. Any questions so far about that? Some pretty cool Matlab stuff, right? All right, so the main point of this exercise, I mean, we actually did a lot here, right? Probably more than you guys, fully processed all at once. But what I hope you got out of it was not actually that hard. If we go back, let's actually open our Python code. Let's see, enable all files. Oops. If we flip back and forth, let's see, what's the next tab is control. So, all right, if I flip back and forth between tabs, it's a bit different, but partly because it uses like different sizes and stuff to display the code for whatever reason. But you can see code didn't really change all that much, right? I mean, yeah, we added some semicolons, we took away some regular colons, we added some ends and such, but it's really not that big of a deal in a lot of ways to port things over from Python to Matlab, right? So that's what I was hoping you guys would kind of take away from it and just get the idea that Matlab code is not so crazy and foreign as Python code. Okay, so any questions so far? Because it's probably about time for a break. All right, so maybe we'll take a break. Okay, so here we are again, just for posterity on the podcast or for the attention deficient, or if you were out of the room. We're going to continue on learning about Matlab now that the Matlab fairies turn out to have visited. Sorry that this is all a little impromptu, but you never know when the software is finally going to show up that you've been asking for. So I think it will actually be helpful to get more Matlab. This is not to discourage you guys from continuing to work on your projects, but I can always have office hours for sort of guided project practice time. So I think it'll be good to keep working on Matlab. And again, like I said, by tonight or tomorrow, I should be able to give you back feedback for both of your outstanding problem sets and your projects, which will hopefully assist you on your project development. And I will try by tomorrow or the next day to get you out a relatively easy MATLAB problem set if I can confirm that we will continue to have MATLAB long enough for you to do the problem set. Okay. And like I said, right now we only have Matlab because I haven't installed the PsychToolbox experiment stimulus delivery software on any of these computers. So we can only sort of work in the pure Matlab context, which is fine though, because this is how we did Python, right? So if you remember last semester, we did Python for about 4 or 5 lectures before we actually got into displaying text on the screen, displaying pictures on the screen, playing sounds and all that stuff, right? So my goal was to kind of do that a little bit with Matlab too, to kind of ease you into the language, and then we can kind of work our way into Python. I'm sorry, Python, PsychToolbox. Okay, so let's do a couple more demos. So one thing I wanted to point out about the last demo, well, actually, the next couple of demos will illustrate this even better. So this is a long way to illustrate a point, but let's do it nonetheless. So I'm going to make a couple of new functions. Oh, by the way, again, you notice that there are various ways that you can make new files and save files and so forth. So you can just go, File, New, or use the keyboard shortcut for that. Again, if you're a real nerd and you do everything via the command line, oftentimes you'll want to say Edit to edit a file or to start a new file. So I'm going to start a new file, and I'll call this one, call this one Very Important Number. All right, so I'm going to make a document called Very Important Number. And again, we ran into this bug over the break. It's probably best if you keep it in your Documents/Matlab folder, and don't do anything to change Matlab out of that directory for now, because your lives will be much happier if you don't have to worry about Matlab finding the correct file. Okay, so this function is only like 7 lines of code. And it's going to do something. So I'm going to sort of illustrate a few different points with the next couple of demos. So you can follow along. It's probably not a bad idea to do so. But you don't have to know exactly what this code does just yet. So that's powers underscore of 2 equals 0:2 semicolon. That's the first line. I'm going to create another variable called prime lim. That's not you or anyone else in this campus named lim. It's short for limit. Equals 7. Prime list equals primes prime lim. Prime ins equal 2 dot caret, a little hat sign, powers of 2, my factors equals prime list, prime ins, and important number equals prod my factors. Okay. So that's the whole function. Probably doesn't make any sense what it does now, right? But that's the file. So I'm going to go ahead. Well, you guys might still be copying some of this code down, kind of, but don't worry if you haven't got it all down, because we're going to spend a couple of minutes on this. So you can kind of be copying while I'm kind of talking through it. So let's see if I did this right. So this function was called what? Very important number. So I'm going to run very important. And when it magically appears, what I'm doing is I'm hitting tab. That completes anything. If there's only one file in this directory called very_im something, and I hit tab, it just fills it in. So if I run the very important, again, if you remember, I didn't explicitly say this today, I don't think, but if you have a file named veryimportantnumber.m and you run the command veryimportantnumber, what Matlab does is it looks for a file named veryimportantnumber.m and it runs it. All right, so it seems to have, well, it ran, right? It didn't produce any output, though. So why did it not produce any output? It's not bad that it did not produce any output. Well, it didn't tell the printer display anything, right? So it didn't produce any text output. And I remember to put my semicolons on all of these statements, right? So it doesn't print all. Now, if I didn't have semicolons on all these statements, let's see what would happen. Okay, and run it again. All right, that produces a lot of output, right? So that means that every line of code here prints the value of the stuff in it, right? Which is sort of useful maybe sometimes when you're debugging or if you're writing a very simple function. But obviously, if you have a very complex file, you don't want to see the value of every variable that's created in the Matlab window popping up, right? So normally, we want to have all of our semicolons in place. All right. However, it is kind of useful because it tells us in the end that the very important number that we're calculating is, just like in problem set 6, the number 42, right? Again, congratulations to those of you that correctly identified. The reason that that's important is because it's the ultimate answer to the ultimate question of life, the universe, and everything, right? So it's a very important number. I'm glad we calculated it. But let's step through what we actually did here. And this will illustrate a few interesting new things about the Matlab language, right? Now, there's a couple ways we could do this. Let's just go ahead and blow your minds, all right? So first I'm going to do one thing. I'm going to type clear, and I'm going to type CLC. What that clear does, very important function, you have to be very careful with it though. Clear gets rid of all variables you've created so far, okay? So you see now my workspace is totally empty. This is useful because sometimes, you have a million variables, you want to get rid of them all and start fresh. So this is just like I closed Matlab and relaunched it basically. And CLC clears all the text in your display, right? So it's a nice fresh copy of Matlab. It's a little faster than restarting it. All right, so if we wanted to go through this function and see what was actually going on, you remember last semester, towards the end, I was like saying, well, it's a really helpful skill for you to get used to stepping through code in your head and figuring out how it runs so that you can understand it better, right? So now that I've made you do that the old-fashioned way, I'm going to show you the way to be incredibly lazy about doing this from now on in Matlab. And hopefully this should work similarly on all of your machines. So I think I've mentioned before that Matlab has a very cool thing called the debugger, okay? And a debugger is just something that lets you step through code one line at a time, so it doesn't all run at once. You can sort of control it and run it a little bit at a time, which is really good for understanding how code works that you've never seen before, and it's also very good for finding a problem in your own code. So if you just have some input and your code produces some output and the output's wrong, there's a lot in the middle that could be going wrong with your code, right? But if you can step through each line of your code one by one and see what happens on each line, you can find the line where something happens that's not what is supposed to be happening, right? So it's, in theory, super cool, right? All right, so there's a couple different ways to enable the debugger, but probably the easiest way is to set what's called a breakpoint. So you see the little dashes? You guys should all have these little dashes on your editor if you've got this file typed in. If you click one of those little dashes, it turns it into a little red circle, which you can think of as being like a stop sign. And what that means is if you run this file and it gets to the stop sign line, it's going to stop right there until you tell it to go on. Okay? So that's also useful because sometimes you don't want to go through every line of code. Maybe your script doesn't break until line 300, right? So you don't want to necessarily step through the first 300 lines every time. So you could just go, like, if the only problem, sorry, to anyone watching on the podcast, there's a bug in my face. I'm just lost my mind. It's probably too small to show up on film. All right. So in other words, if my code, I knew it was working until line 6, I could just set a breakpoint here, and it would just run lines 1 through 5 and stop on line 6, right? But if you want to step through the whole code file, it makes sense to set a breakpoint on line 1 and step through every single line. Okay, so if we set this breakpoint, and I flip back to my editor window, and I say very important number, and I run that again, what you'll see if I go back here, it gives me this little prompt and it gives me a K. I'm not sure why K is the letter, but K means that you're in the debugger right now. Now that means a couple of things actually. So if we go back into the code window, we see that in addition to the little stop sign, now we've got a little arrow saying, this is the line of code that you're about to run. Okay? So we haven't run it yet, but this is the line of code we've stopped on. So from there, we can do a bunch of different things if you go to the debug menu. We can do what's called step. Well, for right now, let's just talk about step and continue. Okay? Don't worry about step in and step out just now. So step means run this line of code and stop on the next line. Okay? Continue means basically, I'm done using the debugger, just keep running normally. Now, if you click continue and you've got like another breakpoint later on, like say I set a breakpoint on line 6, continue will only make it run down to line 6 and then stop. But you know, if you've got hundreds of lines of code that you want to skip through before your next breakpoint, that's a good thing to use. But if you want to go through every line of code to see where your bug is, the step command is really your pal. So let's try that right now. So you can go debug step, and you'll see what happened is we've stepped down to line 2. Now in theory what should have happened is we should have assigned a value to the variable powers of 2 here, right? And one super cool thing about the debugger is you can just mouse over a variable, and if it has a value, it will tell you what that value is, right? So it tells me that powers of 2 is a matrix consisting, it's a 1 by 3 matrix, meaning 1 row, 3 columns, and it's got the numbers 0, 1, and 2 in it, right? Now there's a couple other ways I could look at that. If I flip back to my command window, I'm just going to move it down a little bit, you can see that now I've created a variable called powers of 2 in my workspace, right? So we can see here that there's a variable called powers of 2, and it's got the values 0, 1, and 2. Or I can go ahead, while I'm stopped in the debugger, I can enter stuff into the command line. I can enter any command I want into the command line, and it won't run the code in the file. It won't change anything in the file, but it will let me like look at the variables that I created in the file, right? So I could also, if I wanted to see what powers of 2 was, I could just put its name in, and it would print it out for me, right? So there's lots of things I could do in the debugger. So basically, it basically freezes time, but gives you access to all the variables and everything that you've created so that you can look at them. You could change them if you want to, but that's generally not a good idea when you're debugging because you want to be trying to make your script work right without your outside interference by adding in extra commands that you enter in here. Okay? Maybe this is still a little confusing, but hopefully you're getting the idea. Okay, so what we can learn from this line, if we see that powers of 2 is the number 0, 1, 2, that tells us about a new Matlab operator, which is this colon operator. So this colon operator is also a really super useful thing, and you'll see why in various ways later. But it tells us kind of what that colon operator does, right? Is that if we enter 0, 2, we get 0, 1, 2. If we enter 0 to 7, we get 0, 1, 2, 3, 4, 5, 6, 7. If we enter 4, 7, we get 4, 5, 6, 7. Anybody remember anything in Python that kind of works like this? Does this kind of remind anybody of anything? Well, okay. So Python does use a colon for that, and it's related. It's very related. It's sort of getting ahead of what I was going for, but yes. Let's go back to our friend Python, if this is not too confusing. Anybody remember our old friend range, also known as xrange? Right? So if we said range of 7, it would give us 0, 1, 2, 3, 4, 5, 6. Very similar concept, okay? So remember we said, okay, well, you can replace range with xrange if you want to have slightly better code. But if you remember what range did in Python, range gives you the range of numbers from 0 to whatever, right? And you can specify some other stuff, like when it starts and when it stops. So very similar idea with the Matlab colon operator, right? So 0, 2 means all the integers between 1 and 2. And again, you see a difference between Matlab and Python is that in Python, one weird thing about working with the range operator is when you say range 7, it gives you 0, 1, 2, 3, 4, 5, 6, but not 7, right? It's very confusing. I find Matlab much more intuitive. 4, 7 gives you 4, 5, 6, and 7, right? So that means all the integers from 4 to 7. Now there's all kinds of fancy ways you can also use this colon operator, but we're not going to worry about those for now. Okay. So basically what we know so far is we've we've made a variable called powers of 2. It's got 0, 1, and 2 in it in order, okay, using that colon operator. The debugger is teaching us so much already. Okay, so now we're stuck on line 2. You notice if I mouse over prime lim and hold it there, nothing happens because when that arrow is on line 2, it means we haven't run line 2 yet. We're about to. So right now, if I enter in prime lim and try to ask what it is, it gives me a little error. Now, it's not an error that causes my script to crash because I'm in the debugger, but it tells me that's an undefined function or variable, right? But if I go to the debug menu and say step again, now if I say that again, now it tells me that prime lim is 7, right? Because we ran line 2, we set prime lim to be equal to number 7. Okay. So now we've got 2 variables signed, right? Powers of 2, prime lim. Hopefully prime lim equals 7 is self-explanatory. Let's step through the next line. Now what this was prime list equals primes, parentheses, prime lim. And prime list gives me 2, 3, 5, 7. So I put in, so there's some function apparently called primes, right? I didn't write a function called primes. This is something that's built into Matlab. And I gave it prime lim, which is equal to 7, right? So I gave some function a 7, and I got back 2, 3, 5, and 7. And the function's named primes. Now, I know you're all pretty smart. So what did the prime function do when I gave it 7? And I got back 2, 3, 5, 7. What do you think the primes function does? All right, we'll do fill in the blank. It gives you all of the prime numbers less than or equal to whatever you pass in, right? So if you guys remember, we wrote a function like that last semester in a problem set, right? Now, you guys, or I wrote one and asked you about it, right? Now, you might be kicking yourself because you're like, well, Matlab can just do that, right? If I want to know all the prime numbers up to 100, I can just do primes 100, 2, 3, 5, 7, 11. It's super fast, right? If I want to know all the primes up to 1,000, Matlab can do that. Super easy, right? Again, one of the nice things about Matlab, Python has these kinds of functions too, but you have to track down the modules and import them. Matlab kind of has them all built in by default, or a lot of them. Okay, so we've got a list of prime numbers now, less than or equal to 7. So that's our list of prime numbers. It's a 1x4 matrix, right? Now if we do this next line of code, step over that, we say prime ends, well, what does that mean? 2, colon, little hat guy, powers of 2. Well, if what we get is 1, 2, 4, and what we put in was 0, 1, 2, anybody have a guess as to what this little hat guy is doing? All right, well, I'll give you a hint. 2, so let's forget about the period for a second, or the full stop. If I put little 2, 0, I get 1. If I put 2, 1, I get 2. If I put 2, 2, I get 4. If I put 2, 3, I get 8. 2, 4 is 16. So what does that caret operator do? Everybody remember? Or make sense? Okay, yeah, it's a power exponent operator, right? So 2, 4 means 2 to the 4th power, right? So what was I doing? So I was doing something like that when I had 2 period caret powers of 2. Well, I'll tell you a little secret. Is in this specific case, I don't think I needed the period or the full stop. So if I do 2 caret, whoops, I did need the full stop. Okay. So here's another little weird Matlab issue. Like I said, Matlab, like I'll say a million times, Matlab wants to treat everything as a matrix, right? So that's useful in a lot of ways. So okay, here's a reason that it's useful. Let's say I have my prime list, right? Everybody remembers prime list is 2, 3, 5, 7. If I want prime list squared, oops, that doesn't work anymore. This used to work, I promise. I think, in some versions of Matlab. But it actually gives us a hint at what the problem is. So let's take a step back, actually. All right, so let's do something simpler. Prime list is 2, 3, 5, 7. If I wanted to multiply every element in prime list by 5, I can do that, right? 2, 3, 5, 7 times 5 is 10, 15, 25, 35. Everybody see that? So if we multiply a matrix by a single number, a scalar, Matlab is smart enough to say, oh, what you probably want to do then is multiply everything in that list by 5 and give me the list that's the output of that. That works okay too if I want to, if I want to add, like let's say I wanted to add 5 to each of 2, 3, 5, 7. Prime list plus 5, 2 plus 5 is 7, 3 plus 5 is 8, 5 plus 5 is 10, 7 plus 5 is 12. That's fine too. But it gets a little tricky, like how to interpret certain things. So let's say I wanted to add prime list to the matrix 1, 2, 3, 4. Well, that works also, right? So if I give it two lists that match up in size, 2, 3, 5, 7, and 1, 2, 3, 4, it knows to add 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8, 7 plus 4 is 11, right? However, let's try to do something like multiply. All right, that's a problem. And again, it may not make sense why that's a problem to you guys unless you've done a little linear algebra. Has anybody probably, did you guys do linear algebra in school? Okay. Probably not in this psychology department anyway, right? So unless you did it before undergraduate. So if you did any matrices in your previous mathematics classes, you may remember that matrix multiplication is a funny beast. Matrix multiplication, when you multiply a matrix by a matrix, they need to be certain sizes. I see you guys kind of making little matrix signs with your hands, so maybe you kind of remember this. They have to be certain sizes, right? Matrix multiplication involves like sort of multiplying all kinds of different elements within the matrices and kind of adding them up, right? So remember, Matlab is ultimately a matrix tool. So when you try to multiply matrices that don't match up, it gives you an error, right? Now, what I really wanted to do again, let me just write what prime list is. It's 2, 3, 5, 7. What I really was intending to do when I said prime list times 1, 2, 3, 4, what I really meant to do was the same thing as in the addition case, right? Where I really just want to multiply the 2 by 1, the 3 by 2, the 5 by 3, and the 7 by 4, right? But MATLAB's telling me that's not the right way to do matrix multiplication. So there's a different type of operator for basically the non-matrix kind of multiplication, which is to put a little period or full stop or dot before the operator. And what that means is, no, I don't want to do like linear algebra matrix multiplication. I just want to multiply each element in the list by each other element in the other list, right? So that makes it do it the same way as the addition operator, right? Where I've got 2 times 1, 3 times 2, 5 times 3, and 7 times 4, right? Gives me 2, 6, 15, 28, right? Now, maybe, sort of, it makes sense why you can't do 2 caret prime list, right? Because 2 caret prime list, I mean, it's using an exponent, but it's, using exponents is also doing multiplication, right? So if you try to do any sort of multiplication or division with a matrix or exponentiation with a matrix that doesn't make sense to MATLAB, it'll give you an error. So what you're supposed to do is again, what we really mean is we want 2 to be raised to the power of everything in prime list, right? So if prime list is 2, 3, 5, 7, then 2 to the caret, or 2 period caret prime list gives you 2 to the 4th, sorry, what am I doing? Sorry, prime list is 2, 3, 5, 7. So it gives me 2 squared, 2 cubed, 2 to the 5th, 2 to the 7th. Does that kind of make sense to people? All of this is a really annoying, ponderous way to say that back here in line 5, where we said prime ends equals 2 period caret powers of 2, what that really means is the powers of 2 we wanted were 2 to the 0, 2 to the first, 2 to the second, right? Because we've got a matrix of 0, 1, 2. So now prime ends is 1, 2, 4, which is 2 to the 0th, 2 to the first, 2 to the second, right? Gives us the matrix 1, 2, 4. And that little period or full stop or dot is what makes that correct in MATLAB speak. The correct way to raise a scalar to the power of a matrix. Okay, hopefully that's not blowing all of your minds. I know it's a little bit mathematically, intense, but hopefully not too bad. Okay, we're nearly done. So what we've got now is we've got powers of 2 is 0, 1, 2, prime lim is 7, prime list is 2, 3, 5, 7, and prime ends is 1, 2, 4. Let's step through one more line. We see that my factors, which was set to prime list, parentheses, prime ends, is equal now to 2, 3, 7. Okay? Now, hold the phone. Prepare for mind blowage number, I don't even know which number we're up to now, right? So I just did what looked like a function here, kind of, right? And this is one downside of MATLAB, or it's one thing that's a little confusing. In Python, remember we looked at lists, right? So if we go back to Python and we say my list equals range of 7, oops, not range of y, range of 7. My list in Python is 0, 1, 2, 3, 4, 5, 6. And if I wanted like my list item 3, which is really the fourth item, remember, 0, 1, 2, 3, right, it's the number 3. And if I want to say like my list, if I want all the items from 3 onward, I can do 3 colon, and get 3, 4, 5, 6, right? But in Python, we use these square brackets to indicate we are accessing items within a list, right? So one confusing thing I'll tell you about MATLAB is when we're defining a matrix, we use those square brackets to like put all the elements in the matrix inside a little matrix. But when we're accessing a matrix, we use the same parentheses or curly, or not curly, rounded brackets that we use when we're calling a function, right? So that's a little bit confusing because calling a function looks basically identical to accessing the items in a variable, right? So prime list here looks kind of like a function in Python or a function in MATLAB, but what it's really referring to is the prime list variable, right? So when we say my factors equals prime list parentheses prime ends, what we're really saying is, now this is kind of complicated, right? Prime ends is 1, 2, and 4, right? Now I've just told you that what we're doing is we're using parentheses to access the items in the list, prime list, which was 2, 3, 5, 7. So if we have 2, 3, 5, 7, and we want items 1, 2, and 4, we get 2, 3, and 7. Does that kind of make sense to people? Let's step through, if not, let's step through a little more carefully. Now again, one thing to keep in mind about MATLAB is because it's just different from PsychoPy, numbering of things in lists or matrices starts at what number in MATLAB? I was going to point at you, but I realized I was also giving you the answer. It starts at 1, right? In Python, the first thing in the list is item 0. In MATLAB, it's 1, right? So in other words, if we look at our list prime list, right? Prime list we said was 2, 3, 5, 7. If we want to see what prime list item 1 is, it's prime list parentheses 1, and that's the number 2, right? The second item is equal to 3. The third item is 5. The fourth item is 7. And the fifth item gives us an error because it doesn't exist, right? And similar to Python, if you want to get multiple items, you can do something like prime list 2, 4 will give you the second through fourth items, right? Now the one tricky thing is we didn't want the second through fourth items, right? What we really wanted was the items indicated by prime ends, which is items 1, 2, and 4, right? Skipping 3. So that's a little tricky, but that's a neat thing you can do in MATLAB pretty easily, is you can use a matrix, I know this is going to sort of blow your mind, as the input to the indices or the locations of items in another matrix. So if I say prime list, parentheses, prime ends, right, that's the same as saying prime list, here this makes it a little more explicit, and putting in 1, 2, 4, as a matrix, right? That's saying I want items 1, 2, and 4 out of prime list, right? So if prime list is 2, 3, 5, 7, items 1, 2, and 4 are 2, 3, and 7. Does that kind of make, again, I know we're going, it's probably blowing lots of minds, but this will be a good one to review in the podcast, I think. And again, I'll give you a problem set that kind of helps you step through some of these questions. But basically the idea here is we put in these 3 indices, or these 3, locations into prime list, which was 2, 3, 5, and 7. We got out 3 things that were in prime list, 2, 3, and 7, right? Now, the very last line, thank God, is pretty easy. Let's step through it. We see that we get a little downward pointing arrow, meaning we're still in the debugger and we can still do debugger stuff, but we're about to get out of the code. The important number equals prod of my factors, right? So we said my factors is now the list, or really the matrix, 2, 3, 7. Anybody have it based on the name prod? This is another function, and that we gave it the list 2, 3, 7, and we got out 42, right? So prod of 2, 3, 7 gives us 42, an extremely important number. Anybody got an idea what the prod function does? What's that? Right, okay, yeah. So it gives you, it multiplies all the numbers in the matrix that you give it and gives you the product, right? So, if I wanted to do, prod of 2, 4, 6, 8, that gives me 384, right? Maybe not the most useful function for a lot of things you've done so far, but it can be very useful. Again, when you start thinking of how to do things kind of matrix-wise and mathematically, it's a useful function to have. Okay, so again, we haven't gotten through because I have a whole nother, well, actually, we've got about 10 minutes. I've got a whole nother demo to get through, but it's really complicated anyway. So let's not do it. But I do want to make one more point. So again, lots of things we learned here, right? We learned a lot about Matlab operators. I kind of showed you how to use the debugger, right? So you can like mouse over lines of code, step through them one at a time, see what they produce. You can go in and kind of play with the variables created in the script. But there is one other big lesson I want to leave you with. So maybe I'll go ahead and do this right now. So let me actually just cheat a bit instead of typing all this in, and just put this file directly into my Matlab folder. So I also have another script I made called somewhat important number, okay? So if we open that up, I have another whole script that makes another number, and I might ask you in a problem set to figure out what this function does at some point. Not right away. You guys don't know enough yet, but sometime soon. So if I do the function somewhat important number, and actually this would, if I gave you a question on a problem set asking you to figure out what this did, a smart thing to do might be to set a breakpoint in the first line, run it, and then start stepping through lines to see what it does. So step, okay, we've assigned the number 1 to current num to check. This is the kind of line you maybe don't need to like step through in the debugger, right? Because you know what that one does. All right, now we've got a variable called target found. We set it to false, which we know is equal to 0, so that's fine. Note, sorry, I'm pointing at my screen. Note one thing. It says it's a one-by-one logical. That's just a little side note to note that Matlab has a different kind of data for logical information than numerical information, although it still comes up as a 1 or 0. So it usually is not too important, but it's worth noting for the future. Oops, what did I do? Did I step out of the debugger? How did I break that? Oh well, let me do that again. I don't know how that happened. I somehow killed it. So step, maybe I accidentally said continue, step. All right, so like, see now I'm in, now this is what I think will really help you guys. Some of you I think who are still having trouble with things like loops and so forth. You see I'm on line 6, while not target found, which means while, I haven't yet found whatever my target number is. If I say step, you see it steps into the code in the while loop, right? Whereas if target found was true, it would have then skipped to the end of the while loop. Maybe next time we'll go through this in a bit more detail so that you guys can kind of step through loops and things. And And you see how debugger is really helpful for you exploring the structure of code. But we're just going to step through a couple other lines. I'm going to use the keyboard shortcuts. And you see what we can do is kind of, that was a good one, right? So we had a while loop there. I didn't stay on it long enough. But the test statement, so we have a variable right now called current num to check, which is still 1. We set factor pair is equal to an empty matrix, which is like an empty list. Fac1 is the number 1, fac2 is the number 1, and we wanted to test while fac1 cubed is less than the current number to check. Well, fac1 is 1, 1 cubed is 1. That's not less than 1, right? It's equal to 1. So we skipped over that whole while loop, right? So you guys kind of see how the debugger really helps you think really helps you see how the computer is thinking one step at a time. So this code you should not think of as like some static mathematical formula. You should think of it as a set of instructions that you can step through one line at a time and process for yourself, right? So similar to here, like if whatever, you see that statement in the if statement was, or that condition in the if statement was not true, so it hops from the if to the else without doing the thing in between, right? So we see that target found was not set equal to true, it's still false. If we step over, or if we step past the else, well, if you get to an else, then you have to do the thing that's after it, right? So you would do this, step over that, current num to check is now going to change to 2. All right. Now again, it's not important at the moment for you to have any idea what this code is doing. I'm just sort of showing you the debugger. What I want to do though is say continue and see what's produced. So again, it doesn't really produce any output, right? Because I put semicolons and everything. But if I want to see what the last thing created by the script was, I could check important number, and it tells me that the last thing the script created was 1729. Okay? That is an important number. Maybe again, maybe that's going to go in a problem set. I don't know. It's not important why. That's a somewhat important number, but not as important as 42. Here's one lesson that I wanted to mention. All right, so what do you learn from the fact that if I'm in the command line, well, actually, let's take that back. What have we got here in the command line? If you look at, or in the command line window, if you look at my workspace, I've got a bunch of variables in here called ants, current num to something, fac1, fac2, factor pairs, important number, my factors, powers of 2, prime ends, prime lim, prime list, target found, right? That's a bunch of variables. That's all the variables that I created during both of those scripts I just ran, right? So if I run very important number again, and now I check to see what the value of important number is, it's 42, right? If I run somewhat important number, whoops, still got a breakpoint. Let's just take that off and say continue to let it run through the whole thing. All right, if I now run somewhat important number and check the value of important number, it's back to 1729. Okay, so that's all well and good. Here's the only problem. What we've just done is we've been using sort of regular Matlab code files that are just a list of commands, right? And all a regular Matlab code file like this is it's simply the same as taking all these lines of code and copying them and pasting them into the command window and hitting enter, okay? It's just a collection of things. It's just like you entered them straight into this command window one by one. In a way, that's fine, but anybody see a giant problem with having two, like, let's assume these functions do something that's actually important. Anybody see a giant problem with having two functions that work this way? Potentially. Maybe not if you're responsible, but if you get confused easily. Anybody see any problems? Yeah? Well, okay, right. So you notice that I have two functions. They each have a bunch of their own variables, but they each create or use a variable called important number, right? And maybe we're interested in what the final value of that number is. That's a problem. Let's say I was really interested in, finding out what my very important number was. If I checked it right now, I see that it's 42. But let's say I clear out all those variables, and let's say I've just started a fresh copy of Matlab. And I'm running along, and I run very important number, and I create a bunch of variables. And then I do some other stuff. All right, whatever. And somewhere in there, I run the somewhat important number code, or some code that calls the somewhat important number code. And then I want to check and see what my very important number was. What did I just do? Somehow I made a buzzing noise. That was weird. Okay, well, we're almost at the end, so we won't worry about it. I see that my important number is 1729, but it's not what I thought it would be, because I was thinking about what would be the output of very important number, which is 42, right? So this is the problem, is if you have two of these script files that each use the same variable names, they can each use that name and dump the values into your workspace. And it gets very easy. Remember, we talked in Python about the idea of namespaces, right? And do you guys remember what we have to what has a different namespace than just your regular Python code? Everybody remember functions? Okay, so in Matlab, what I'm going to tell you to do, this is sort of the final lesson of today that we're going to do, is never. There are reasons that sometimes you'll want to have bare code files like this, but not in this class ever again, okay? So this is the kind of thing that once you learn to use Matlab responsibly, you can get away with having some of these bare code files sometimes, but they're going to be more trouble than they're worth most of the time. So what I'm going to tell you to do from now on is, unlike in Python, where your main code is not in a function, it's just your main code, in Matlab, I'm going to tell you to make everything in every code file a function, okay? And the way you do that, and we're going to get more into functions later, but the easy way you do it, if the function doesn't need any input or produce any output, is to just put the word function and then the name of the function at the top of it, okay? And again, I know this is a real quick introduction. We're going to get into the details later. What this does is it goes from making. It's just like the def word in Python, but you actually just write out function, which is probably a little bit easier. So it goes from making somewhat important number just a collection of statements to a function called somewhat important number that does some stuff, right? Now we could assign it to have inputs and produce outputs, but we're not going to bother to do that just yet, right? So right now this is just going to be a function that does stuff but doesn't produce input or output. And we're going to do the same thing with very important number. Function, very important number. And one note is that Matlab is going to complain at you if you make the name of the function anything but the name of the file. So if I wanted to call it very numblizzle, it's going to give me one of these little warnings. It's basically saying Matlab wants to refer to this by the name of the file, so you should really name your function the same thing as the file is named, okay? So if we make a function called very important number, that's okay. Now let's see what happens if I created let's clear it out like I had started a fresh copy of Matlab. If I run very important number now, what variables does it create in my workspace? Or if I run somewhat important number, what variables does it create in my workspace? None, right? So in other words, if I want to see what my important number is, or any of those other variables that we made, it says there's no such thing as important number, because now all of those variables are private to each of those functions, right? So all those names can only be accessed within the function that creates that name. So that's all well and good. That's one nice thing, is that keeps the very important number function from writing over the value that's in the somewhat important number function, or those names from interfering with each other. The problem is, of course, now we don't know what the important number is, right? So what you really have to do is, the sort of dumb, easy way to do this is just to say disp important number, right? So, or let's put it in parentheses. Right, so to display it or to return it as output, which is something we'll learn in the future. So if we just put a line to display the result, now when we run very important number, Oh, I saved somewhat, but I didn't save very. All right. If we run very important number, it tells us the answer is 42. If we run somewhat important number, it tells us the answer is 1729. That's a way to get the output we want without dumping a bunch of variables into our workspace. And again, this is maybe not a big deal with like a 10-line function, but if you have a function that's 200 lines long, and it calls another function that's 200 lines long, and that calls another function that's 200 lines long, you don't want everything having names that can like change the names of variables in your other functions, right? Maybe I'll give you a better example of why that's a really bad idea next time. But this produces the output we care about. It prints it to the screen in this case. But we don't have this name interference. We don't have all these variables cluttering up our workspace. So that's a very quick introduction to defining a function in Matlab in a very dumb way by just sort of putting the word function at the top of the file with the function name. Next time and beyond, we'll look at things like how to get inputs and outputs from functions, and maybe do some more illustrations of why this is important. Okay, I know that's a lot. You're not meant to have caught all of it. What I'm hoping you'll just do is just kind of recognize some of the parallels. I mean, we really haven't done much except for a couple of mathematical operations. We haven't done much that's different entirely in MATLAB than it is in Python, or that doesn't exist in Python. We're just learning different ways of naming things. So I don't want you to catch it all, but I want you to sort of start getting familiar with that stuff. So any questions? Any general? Yeah.
Can you go back to the why was the answer,
To what? Sorry.
Can you go back to the given functionality?
Yeah. Okay.
Okay. Why is the answer so important number indented further on?
That's a good question. Probably has to do with your default number formatting. Let me see something. You don't have to know what I'm doing here. Magic. Don't pay attention. No, that's not it. Something having to do with the disp function does some things to try to figure out what the smart way to print stuff is. It's not always obvious what that is. I mean, what I would have really done if I had had more time, which now I'm going to do it anyway and take up that time, is I might have said like, you could make it a bit nicer by saying something like, your output is, and then you guys remember num to stir, important number. So what I just quickly did there is combine a couple of strings. Let's do the same thing in this file. Now it's going to be formatted a bit more nicely, like that. So that's one way you could do it. I mean, so that I was being a little bit shortcutty, but that's probably a better way to do it. Okay, any other questions? I know we're a couple minutes past. I probably need to go to a talk. Okay, awesome work, everyone. Hopefully you followed along okay. I'll keep you posted on problem sets and stuff for next week as we sort out the Matlab issue. And to all of you out there in internet land, you know, you'll just have to wait and see what happens.